Okay, I'm going to go through another pulley question for you. This is more of a traditional examination style question involving pulleys. Let me just show you what it is and read it out to you. So two particles, A and B, of masses 0.4 kilograms and 0.8 kilograms respectively, are connected by light inextensible string. Particle A lies on a rough horizontal table 4.5 meters from a small smooth pulley which is fixed at the edge of the table. The string passes over the pulley and B hangs freely with the string taut 0.5 meters above horizontal ground. A frictional force of magnitude 0.08 G opposes the motion of particle A. The system is released from rest. We need to find the following: the acceleration of the system, the time taken for B to reach the ground, the total distance travelled by A before it comes to rest. Here we go, lovely. Like I said, mechanics questions, great, I do love them, but they're really rather wordy, aren't they? Okay. Our first job is to draw a force diagram to see exactly what's going on here. Okay. So what I do is I normally represent the table like that, the pulley like that, and then the string passing over the edge of the table like that. Okay. The least complicated you can make your diagram, the better. Okay? You don't want it cluttered up with lots of things. And I'm going to label the particles here and here like that. Okay. Now it did say I think particles A and B, so I'm going to put that as particle A there and particle B like that. Now we need to know the masses of those particles. So the mass of particle A was 0.4 kilograms, so the weight downwards will be 0.4 G, and for particle B, let me just check what that was, 0.8 kilograms. Okay, I've got those notes in front of me here, basically they're my cheat notes, so I can actually look at them without actually looking at the question all over again. Okay. What else have we got to label? Well, this is a light and extensible string, of course, so you've got tension acting there, and you've got tension acting there. Okay. And what else did it say in the question? Let's just repeat this bit because it is really rather important. It says particle A lies on a rough horizontal table. Now when that says rough, that means it's not smooth, which you might think sounds obvious, but in mechanics it's important. If it's a smooth surface, that means there's no frictional force. Okay, the frictional force is something that is holding it back, preventing it from moving as quick as it possibly can. It's slowing down, it's a retarding force. Okay, but when there is a rough table, there's a frictional force. Now usually we label that as F for friction. Okay, but what it tells you in the question is it tells you what that frictional force is. Okay, so we can actually write that in, but just bear in mind sometimes you need to actually work out what the frictional force is or do something else with it. But this question we don't actually need to. It says the frictional force was 0.08 G, 0.08 G. So I'm just going to put it in like that. Okay. Now you could argue there's another force to put in. Yes, the normal reaction force. But given that we know what the frictional force is, we don't need the normal reaction force. Okay. Later on you'll see how friction and normal reaction are actually linked together. But we don't actually need normal reaction in this. Now those are all the forces that we need. Now it does say that the system is released from rest. What's going to happen? What happens is traditionally this object moves downwards and this object moves towards the right, towards the pulley. Okay, so I'm going to put the accelerations in as follows. So this for particle B is moving downwards, and then as that happens, A is moving this way. Remember, because it's a smooth pulley, light inextensible string, the tensions are equal and in magnitude, and the accelerations are also equal in magnitude too. Okay, and then we're ready to go. We're ready to solve part A of the question. Traditionally, you're asked to find both the acceleration and the tension. Okay, I don't know why, but in this particular example, we're only asked to find one of those, but we can go and find both if you want. Okay, so what I'm going to do is I'm going to just look at particles A and B separately. Doesn't matter which order you do it in. I'm going to choose A first of all. So A, what's happening? It's moving towards the right, so the positive force is T, and opposing that is that frictional force we're given, which is 0.08 G, and that's equal to the mass, which was 0.4 times by the acceleration. Okay, I've just noticed there's a rogue K there. It shouldn't be there, should it? It's 0.8 G. Apologies for that. And that's equation 1. Equation 2, for particle B, it's moving downwards, so 0.8 G, and then opposing that is the tension, so subtract T is equal to the mass times by the acceleration, 0.8 A. That's equation 2. Solve them by adding them together, so equation 1 plus equation 2, so what we're going to get, 0.8 G subtract 0.08 G, so that's going to be 0.72 G, the T's will cancel, and then this and this, that's going to be 1.2 A. Okay, right, at this stage, just don't bother with the mental maths, okay, particularly in the exam, just pick up the calculator because the numbers are just a bit awkward, aren't they? Okay, so 0.72 divided by 1.2, okay, you can either write the answer as A is equal to 3/5 of G, or let's just work out what that is, times by 9.8, okay, 5.88 or 5.9, okay, depends how you want to leave your answer. If you want to leave it to two significant figures, then it would just be 5.9, wouldn't it? Okay, let's work out what T is while we're doing it. I know the question didn't say work out T, but it's a good idea just to do it as a matter of course. Okay, so T will be 0.4 times by A, so that's going to be divided by 9.8. Yeah, so 2/5 times that basically, so 6/25 G, and then added to 0.08. What's that as a simplified fraction? So I've gone all lazy, haven't I, with my calculator? Okay. Despite how many times I say, you don't need to use a calculator for this, I've just gone ahead and sort of use the calculator just to speed things up, really. So 8/25 G would be the tension. So what is 8/25 G? It would be 3.136 or 3.2 to two significant figures. Okay, I suppose you should include units, meters per second squared and newtons, but obviously you can see I haven't. So that's the first part of the question done. Okay, let's have a look to see what we need to do next. Part B, find the time taken for B to reach the ground. Okay, so what I've done is just labelled here, that's how high B is above the ground. So B has got to travel 0.5 metres. It's another SUVAC question, isn't it? Okay, so we had A is 3/5 G there. So let's just write it again here. So A is 3/5 G. The distance it's got to travel is 0.5 metres for it to hit the ground, and the system is released from rest again. Okay, normally they are released from rest. So U is equal to 0 metres per second. We've got to find what T is. So find T. So S equals UT plus half AT squared. Again, should do it, shouldn't it? Yeah, that should do it. So you've got S is 0.5, so that's right then there's a half, and you've got UT, so that's 0, and that's equal to a half times A, so that's going to be 3/10 G multiplied by T squared, and that's what we've got to find, isn't it? Okay, so T squared will be, so a half times by 10, so that's 5 divided by 3, so 5/3, and we've got divided by G as well. So what we want to do is find the positive square root of 5/3G. Again, calculator time there, isn't it? So 5 divided by 3 divided by G. Okay, so that's 25/147. Square root of that is 5√3/21, not appropriate. 0.41, 0.4123, etc. But it's best to round it to three significant figures, to be honest, because we're using G, aren't we? Okay, so that's that part of the question done. Okay, part C. Find the total distance travelled by A before it comes to rest. I do love these questions because there's a lot of things going on. Okay, we've got to just break this down and see what's happening. Okay, so what's happened is that B has hit the ground, isn't it? Okay, B has travelled 0.5 metres to hit the ground. A, meanwhile, has travelled that same 0.5 metres, okay? So initially A moves 0.5 metres. But what happens is A then continues to move. B just stops dead because it hits the ground, but A, because it's significant distance away from the pulley, it's going to keep on moving, it's going to slow down, okay? So what's happening is A moves the 0.5 metres there, and then it will just slow down, eventually come to a rest. And we've got to work out that total distance, okay? So really the question is broken up into two parts. We've got to see how far it moves in the first bit, obviously 0.5 metres, but then the more challenging bit is how far it moves for this bit, okay? We need to find what the acceleration is going to be, okay? Because once B hits the ground, the string is slack, the whole thing's going to slow down. We're going to have to find out what that acceleration is. Now, how are we going to do that, okay? Well, we'll know that at the end of this motion, the final velocity of that object will be 0 meters per second, okay? What's the initial velocity? Well, we don't know what that is, okay? And what we've got to find what the distance is. So there's a lot of unknowns there, aren't there? This is why it makes it quite challenging, okay? Well, are there any of these that we can find, okay? Well, obviously we know v is going to be 0 because it's going to stop. The acceleration, we can find that using F equals ma, okay? And u, we can also find that, okay? Think about how we can find u. Well, what happens when B hits the ground? B will hit the ground, okay? And we've already worked out the time it takes for it to hit the ground, but B will hit the ground with a particular velocity, won't it? With a final velocity. We've got to work out what that final velocity is, okay? As a reminder, the acceleration was 3/5 g. Yes, the initial velocity was 0 meters per second, and the distance moved was 0.5 meters, wasn't it? Okay, so we can work out what v is from that. What's the best equation to that? V squared equals u squared plus 2as, I think. So v squared equals u squared plus 2as. And we can work out what the final velocity of v is. That is the velocity, speed with which B hits the ground. Okay, so you've got 0, and then you've got 2a times by s. So 2 times a half is 1, so you just get a. So v squared is going to be equal to just a, which is 3/5 g. So v itself is going to be equal to the square root, the positive square root of 3/5 g. We don't need to work out what that is. Well, you probably want to, don't you? Okay, but we don't actually need to work out what that is. I'll do it anyway. So 3/5 g is 147 over 25, 5.88, all very nice. The square root of that is 2.4248, a third, basically. It's best to leave it like that because we're going to use that again. Okay. Now, that gives us this then, you see. So now we've got what the initial speed is. Okay, so it's going to be u squared, should we call it, is 3/5 of g, or u is the square root of that. Okay, remember what I'm talking about here is what is happening for particle A as it moves from here to here after the 0.5 meters is done. Okay, so the initial speed is that, because when B hits the ground, A is still moving, but that same speed. Okay, so the initial speed is going to be root 3/5 g. U squared equals 3/5 g, in other words. V equals 0. The acceleration, how are we going to find that? Well, we're going to have to use F equals ma on this. Okay, now what's changed is that we don't have the tension anymore. Because what happens is, as B hits the ground, A keeps on moving, the string becomes slack, okay? It becomes slack. If the string is slack, there's no tension in there anymore. Tension is only there when it's a taut string, okay? So it becomes slack. So the only force acting on A is this frictional force here. And because it's still moving towards the right, because it's still moving that way, that force is going to be a negative force, negative 0.08 g, which is what you'd expect because A is slowing down. So you expect the overall force to be negative. So that is equal to the mass times the acceleration. The mass of A is 0.4, so 0.4 A. So you've got A must be equal to, so again, calculator time, 0.08, and divide that by 0.4. Okay, it gives us 1/5. So it's going to be negative 1/5 of A. Okay. Oh, sorry, beg pardon. What am I talking about? Negative 1/5 of G. Yes. 0.08 divided by 0.4, 1/5. Yeah, negative 1/5 of G. Okay, so that's our acceleration. So what I'm going to do is I'm going to fill that in here. The acceleration is negative 1/5 G. Okay, remember it's negative because it's slowing down. It's a retardation, isn't it? Okay. Now, if you don't mind, I'm just going to rub some of this working off the board because it's getting a bit. Well, there's a lot of stuff there, isn't there? Okay, in other words. So what don't I need? Look, I'm going to get rid of this diagram if you don't mind. Okay, if you need to see it again, you just rewind the video. Okay, but I'm just going to get rid of that because I've got everything that I need to be able to answer the question. Okay, so total distance moved by A is equal to, remember we've got the 0.5 meters added to, and we're trying to find this value of S here, okay, because that's the 0.5 meters, and then this bit here we'll get from there. So we can do that using these, A, V, U, S, and the equation to use there is V squared equals U squared plus 2AS. You probably wonder why I put the U squared there, because yeah, well, when you experience enough, you kind of know what equation you're going to be dealing with, which is why I left it like that. Okay, so V squared is 0, and then U squared is 3/5 G. So put it in like that, plus 2AS. So that's going to be subtract, because A is negative, 2/5 G multiplied by S, which is what we want to find. Okay, great. Let's just simplify this equation just a little bit. Okay, so you've got 0 is equal to 3 subtract 2s. What we've done to simplify it, multiply both sides by 5, so the fifths cancel, and divide both sides by g, so the g's cancel. So 3 subtract 2s. Okay, that's quite simple, isn't it? So you've got 2s is equal to 3, and then you get s must be equal to 3 divided by 2, so that's 1.5. Okay. So that's quite far actually, isn't it? 1.5. Okay. So plus 1.5 meters, and then your total answer is distance moved by A is 2 meters. Okay. Right. I'm hoping you found that example very helpful for you. Okay. If you need to, just run it by again, because what we've just gone through here is really quite an important example. Okay. The examiners really do like that sort of question because there's a lot of mathematics in there. There's a lot of stuff that needs to be done. You've got to use the F equals ma. You've got to use the super. Okay, you've got to consider what is happening as the object moves while it's still connected via the taut string, and then what happens after one of them hits the ground, and then it moves with the strings slack. So there's a lot of stuff going on there. Okay, but I really do love this sort of question. Hope you found that helpful. I'll see you again.